Greetings, weary conference travelers. I'd like to begin this talk with a story of redemption. This story is 100% totally accurate, by the way. 1,000 years ago, deep in the forests of Bavaria, there lived a plucky engineering team who were working to build a magnificent castle. They had been building it for some time, and they were proud of their work. But all was not well in this castle. There were some older sections, deep in the catacombs, that become overly complex and unmaintainable with non-Euclidean geometry. Every so often, when one of the team members would go down to perform repairs on these older, deeper levels of the castle, they would immediately become lost among the mess. There were no signs to help guide them, except for the occasional code comment scrawled in blood that said things like, "To do refactor," or "Here be dragons." For you see, dear traveler, this labyrinth was home to a horrifying monster. The monster's name was legacy code. If the engineer did not tread carefully, the monster would quickly make itself known. When this happened, the monster could trigger a production error, which would anger the castle customers and disrupt progress on new castle features. Till one day, an outsider joined the team. She had just stolen some badass weaponry from the gods and was feeling pretty overconfident. She said to the other team members, "Why don't you simply kill the beast and be done with it?" "One does not simply refactor the beast, though," said one of the more cynical engineers on the team. "He is the amalgamation of years of cruft. There are no unit tests to control him, and his hide is 3 inches thick and made entirely of regular expressions." It seemed hopeless, until another member of the team approached the outsider and pulled her aside. Turns out he was the court jester. "There must be some kind of way out of here," said the jester to the thief. "There's too much confusion in the area." You get the rest. He shared his plan with the outsider. And through the power of teamwork and regression testing, and a few well-choreographed space battles, they were able to ultimately defeat the beast. Morale amongst the builders was up, and they were able to go on building those sweet, sweet castle features that they'd been planning for so long. I should introduce myself. My name is Christian Schlinsker. Here's a photo of me with my twin sister. Her name is Wednesday. I'm a JavaScript engineer at Bugsnag. Bugsnag is an error monitoring service that helps developers fix bugs or see bugs in production code. One thing that customers use Bugsnag for is that we provide a safety net that helps alleviate the fear of making changes and rewrites. When an exception happens, we catch it and they're alerted about the problem. This is especially important for us here at ForwardJS because, as you know, in the front-end development community, we have constant complaints about churn of all the new technologies that we have to deal with. We are blessed with a flurry of innovation of new ideas, but this is a double-edged sword. Sometimes it can be overwhelming and you can find yourself left behind current best practices in dealing with the deprecation warnings or because of the differences of framework versions or having to replace some new technology. Compounding this problem is that on front end there's a comparative lack of testing. This is because tests are historically been somewhat difficult to write. And changing this legacy code is all the more treacherous. At Bugsnag, one of the legacy items we've been working to deal with is the CoffeeScript problem. CoffeeScript used to be great. I mean, it's still great, but JavaScript's better now. It's introduced a lot of the features that we had CoffeeScript for, like classes and fat arrows, and it's gone even further and added its own nice features like async await and object rest spread. Also, it has way better tooling. This is a side effect of the fact that the JavaScript community is just bigger than the CoffeeScript community. So we can use tools like ESLint or Flow or TypeScript to help make our code safer and easier to change without fear. Also, we have great things like Prettier and code mods to help, or Prettier, which to formats code, and code mods that will help upgrade between different framework versions. This is especially a problem with React apps like ours. The CoffeeScript support in React is not so great. So CoffeeScript has to go. But how do we do it? Our first instinct might have been to do a major rewrite and just get rid of all of it and rip the Band-Aid off. But major rewrites are extremely risky. And also, a lot of this code is not tested. So imagine you're one of the Bugsnag customers and the dashboard breaks when you're trying to deal with your own critical issue. It wouldn't look good. It's pretty bad when your debugging tool is also buggy. Another problem is that if we took all that time off, there would be a halt in roadmap progress. And the product team might get a little impatient with us, waiting for us to fiddle around with all this rewriting that we're doing without shipping new features. So how do we deal with this problem safely, with minimal disruption? Our ultimate solution was to do a gradual rewrite, interstitial with doing new feature work. Every once in a while, we would go on a binge or just take one module at a time, test those changes manually, deploy to production, and repeat so often time permitting. This, as you know, this process of changing a module without changing its behavior is called a refactor. The result is that overall it's been working well, but there were some shortcomings. With some of the more complicated code, some bugs are still slipping through. This goes to a problem with manual testing. Is that it's very repetitive, and often you get lazy and maybe take shortcuts. It's also difficult to understand the scope of a module by testing it through the browser. And it's also difficult to know how much of it has been tested and which edge cases you might have been missing. So we thought it might be nice for whenever we go to convert one of these modules, we set up some paranoid unit testing around it in order to make sure we're not introducing new regressions. We've already been using Jest to do unit tests for new code. But it turns out some of its features are especially nice for testing untested legacy code. So what is Jest? Jest is a unit testing framework from Facebook that has grown into the go-to testing framework for React. It's got some really nice features to make front-end testing more enjoyable, and their tagline is just delightful JavaScript testing. One benefit of it is that it helps us add tests quickly, and the tests themselves are very fast. It's also got built-in code coverage. This can tell you when you're testing a module if you're missing any edge cases that you weren't thinking about. Another great feature is snapshot testing. According to the docs from Jest, snapshot tests are a very useful tool whenever you want to make sure the UI does not change unexpectedly. It comes from this idea of screenshot testing, where you would set up automated test suite to take screenshots of a running app in a browser. Then you do a visual diff, and it will alert you when something changes. Then you would go back and check these diffs and see if that was an intentional change and update the screenshot. Some problems with screenshot tests, even though they're a very useful tool. One is that browser tests are kind of finicky. They have to launch a browser, and this process can sometimes be buggy. And also the fact that you're doing visual diffs means that they fail really frequently. Or worse yet, so devs end up just sort of ignoring the failures, ignoring the test failures, or just hitting OK. Or worse yet, they push it off to QA and make them do it. Also, they tend to be very slow because they're running in a browser, and booting up the app takes a while. So if we want to write large numbers of them and use them as a tool to help us debug or introspect an existing module, it's going to be difficult because they're not very well suited to the normal debugging refactor flow. Just snapshots get around this problem by taking advantage of the way that React components work. Think of a React component as a function that takes in data and spits out DOM. We can in a test, we can render the React component to JSON and then put a snapshot around that JSON and capture its output. So when this test runs the first time, it'll save the DOM output to a snapshot file. And that snapshot file lives next to the test. And it looks like this. You can see the DOM output from that component. If we ever introduce a change in that file, if it changes unexpectedly, the test will fail. And it'll show us exactly how it changed. If that was an intentional change, we can just update the snapshot and go on, and it will replace the file. Then you commit these snapshot files to the CI server. So if something breaks in later on, the CI will fail and it will prevent you from deploying. So normally when we think about testing, we think about these different levels of testing. We have UI tests, which are slow and expensive, but they give you greater confidence. You have integration tests, which are kind of in the middle. You have unit tests, which are fast and cheap, but give you less confidence. When I think of snapshot testing, I kind of think of them as UI tests that behave like unit tests. This makes snapshots perfect for regression testing. Say I have this component that I want to refactor. I want to make sure its behavior doesn't change. I can assume that it's working correctly now, because there's no bug reports. So if I put a snapshot around it before or during the refactoring, the snapshot should tell me if I introduce any regressions. Snapshots can be used for more than just UI. They can actually capture any JSON serializable value, and so we can use it for regression testing any type of function. To show that, I have a mostly real example of regression testing a dashboard feature. In our app, when you're looking at error reports, you can use these filters in the filter bar to filter those reports. And when you're doing that, when the filters change, the UI app serializes them and updates the browser URL for the page that you can copy that URL and send it to a coworker, and then they'll see the exact same filters that you saw. When the coworker loads the URL, we parse the filters back out during the initial page load and apply them to the UI. Here's a chunk of CoffeeScript code that handles this. It's kind of big, and I want to convert it, but there's a lot of edge cases in here, a lot of places where I might mess up. So I'm not going to worry about those edge cases for now. The important thing to note about this function is that it's a pure function. It takes in a string, creates an empty object, builds up the query parameters in that object, and then returns it. So it should be easy to snapshot test this thing. First thing to do is find the happy path. I can get the input by just copying and pasting it in here. But if it wasn't something like that, I could just put a console log at the top of the function to get a real input. Then I call the function with that input, and then I do a snapshot capture of the result. That's passing, which means there is no syntax errors or missing dependencies. But I can't really tell if this test works correctly until I've seen it fail. So I can easily make it break by changing the functionality. And it should break the way I expect it to. It does. It was expecting an object to come back, and it got undefined. So that means the test is good. And I can also look at this to help me understand the behavior of this method better. Next, I can read line by line through the function to identify various edge cases. For example, here it looks like we need to handle both the presence and absence of question marks. And also, it's doing something related to replacing plus symbols with URL encoded space symbols, which seems to have something to do with backend browse and some other legacy issues. But I don't really need to worry about that detail so much, just want to maintain the behavior. So I create some tests for both of those and use the same procedure. I can comment out those pieces of code and make sure these tests fail to make sure they're testing the right behavior. Using this process, I built up a series of edge cases, or smoke tests, to help me make sure there's no regressions. I can use the code coverage tool to highlight any areas that I missed. Next step is to actually do the conversion. To speed that up, we use this tool called Decaffeinate. the way it works is that it's, unlike the CoffeeScript compiler, it's going to produce idiomatic ES6 code rather than ES5 code, or mostly idiomatic ES6 code. It's not perfect. It does a pretty great job, though. This is what that looks like. So yeah, we have exports and let statements. So it's ES6 code. And it looks pretty good. Decaffeinate does a great job of producing behaviorally equivalent ES6 code, but it prioritizes safety over style. So there's some things in here that will still need to be cleaned up, which means there's a lot of areas where I can make mistakes. Good thing we have those tests now. For example, there's all these extra return statements now. This is a result of the fact that CoffeeScript has implicit returns. And in order to maintain that behavior, it has to make them explicit in the JavaScript. But I don't want to just leave these around for some other developer to stumble on this craft, so I want to remove them. So I can go through and start removing them. If I remove one that's important, that I actually did need, the snapshot test should tell me about it. The last and final step is to finish all the cleanup, and eventually we have a working, beautiful ES6 file. But I leave that as an exercise to read it. So one thing I didn't show is how do we handle side effects. We've seen how snapshots work to test pure functions that return a data structure, but they're not so great at handling side effect code. For example, imagine this function that's going to generate a new project and post it to an API endpoint. I commented out the messy details that would actually make this scary, but just imagine that they're there. These are the details that are important. It's going to create a project object, do some complicated, fancy stuff to initialize it, and then at the end it's going to hit this API endpoint with that project object. There's no return value here, so I can't snapshot anything. So I use what's called a spy. You can use a Jest to spy on the post method of the API service. This spy will allow me to intercept calls to the function, make assertions about them later. I then call the function to trigger a side effect, to trigger the side effect. Finally, I place an expectation that the spy should have been called. Again, I comment out the behavior that I was expecting to cause a failure. I see that it did fail. But I'm not happy with this, because I want to also make sure that the side effect function was called with the correct arguments and that the structure of the project object was maintained in the end. So spies do this thing where they keep track of all the calls that have been made to them in the test. And I can use that to make an insertion about the array that matches the snapshot. I can use that to make an assertion about the arguments. If I can say that last calls object should match a snapshot, then I introduce some bug in the project generation code. It should show me that it didn't receive the exact arguments that it was expecting. And I wouldn't have to set up any complex exact data matching expectations in the test. I just want to assume that it works the same way that it did before. There are some other drawbacks to snapshot testing. They can't catch everything. They're still pretty low level, and because they don't exercise the whole app. These are still unit tests that we're talking about. So it might be best to use them in combination with other tools, like a light bit of UI testing or integration testing for especially scary pieces. Also, they won't catch CSS regressions. And they won't tell me about browser differences because Jest runs in a node environment in order to make it so fast. But luckily at Bugsnag, we don't have to worry about browser differences so much because all our customers are developers. And you all keep your browsers upgraded, right? Final result is that overall we're happy. The legacy code is disappearing. Future changes have been easier because this code is safer and we're able to use all the great ES6 tooling with it. We have to roll back deploys much less frequently. Thank you. Do we have time for any questions? Or we just want to go straight to lunch?
I wanted to add a note to the decaffeinate. There's a side project called bulk decaffeinate that takes care of
Yes.
the mark wrangling. So if you just use decaffeinate straight up, you're going to lose a lot of these lanes and just the file name.
Okay, so bulk decaffeinate
Bulk decaffeinate
will
takes care of all the steps of renaming the file, estimating the steps, so you actually get the people.
can it still work on a single file at a time?
Yeah.
Oh, that's cool. Yeah.
Do you also use Snapshot to deploy API calls or other services?
Yeah. It's a useful tool for recording like a API call that's going to receive structured data because it will show you immediately like the differences in that data. So if you want to make sure that the data that's going to that API call is the same as before, then you can. This is like a lightweight, fast way to do that.
I mean, like in terms of doing integration testing, so putting responses from third parties, you guys use that?
No.
Say anything about moving from browser-based testing like Karma to something that's running Node that you are?
We were doing browser-based testing in Karma, and the way we actually moved to Jest very quickly because there's some nice code mods that will do it for you. That will do a lot of the work for you of renaming the. We had Mocha in Karma, and it will rename the. Change a lot of the Mocha tests to turn them into Karma tests or into Jest tests, which use Jasmine as their API.
So like, it seems like the snapshot testing is very character by character, using a GIF, just like
Mm-hmm.
the other character by character comparison. Is there any involvement around like when turning DOM into serializing it based on like if you introduce a new line into attributes in the DOM, it doesn't really matter. It doesn't matter here.
It does matter. No, it's a the snapshot's going to record whatever you give it. So if it's you're giving it a value, and it's going to record that and just tell you if that value changes. So it's useful to say, I don't know what assertion I need to make here. Just tell me, did this thing change? You would if you need to test other things like value changes, like side effects happening and things like that. You need to use like spies and other types of assertions, and all of those are sort of built into the unit testing framework. This is one piece of it.
You need to know if that's the handling on the DOM element.
Yes. So it's in a React context. What would happen is that you would trigger the event on the component level, and then you would like record another snapshot. So you would have like a before and after. It's like should be the initial render. Then I introduce a click, and then I want to expect that the second render after the click is also the same. You can do multiples throughout any test.
Did you classify Jest tests or integration type tests?
It's a unit testing framework, but you can use it for doing integration type tests. But it's not fully integrated because it's not in a browser.
How accurate is the proof of rate as far as
It has some problems. It's more of a lot of times I use it just like for suggestions and stuff like that. And also, it's got some issues with CoffeeScript. So the way we get around that is sometimes I'll just run the automated conversion first, and it produces a converted file next to the old file, which is nice because you can compare them while you're finishing up the changes, and then you can test against the new file to generate like the code coverage, and then confirm that your tests are right against the old file. You just switch which file you're using when you're in the test when you're importing it. Yes. Yeah, mocking like the Jest includes a full like mocking library. Mm-hmm. Yeah, I didn't actually show this feature, but it just will, using the import statements, it'll determine which files a test is dependent on, and if one of those files changes, it will only run the tests that are dependent on that file. So by default, they live in a, I have a slide that shows this. By default, they live in a folder called like underscore snapshots that lives next to the test that you that generated them. So it follows this convention that you have like a source file and then a test file for that source file, and then like it will generate the snapshots. Let me see if I can jump to it. Here we go. So yeah, if I have this test that generated a snapshot, it would generate it in this generated folder next to it. And then you could go like click in there and look at it. They're designed for components, but you can use them however you want if you want to assert that some complicated value doesn't change. Yeah, you could if you're using Redux. Thanks, guy in the back. You could put a snapshot around your entire store state, and if you're doing like a refactor, you're like splitting like one reducer into two reducers or something like that, then that would tell you if like the overall state changed at all. Yeah, I mean it's a big file, but so they might have like big output, and you maybe would do a more fine-grained one. But what you could do is you could do like one sort of big super integration paranoid test, and then you have like some smaller tests that you're like just running while you're working on a small piece, and use like a multi-layered protection approach that way.
In terms of saving large snapshots in JSON, is there any issues with like the ordering of keys? Like it's line by line, and your key ordering changes when you serialize the JSON. Have you looked at that issue, or does it feel like it needs to go?
I have not run into that issue. It generates the names of the keys based on, well, it doesn't actually store the files in JSON. It's a custom file format. It's actually a JavaScript file and exports the responses. Actually, that's on the next slide here. So yeah, it's a JavaScript file, and it's exporting the different values. And this name here, the link renders correctly, is generated based on the test name. And it does like a unique like number thing there too. Cool. I think that's it's time for lunch. Thanks, everybody. If you have any more questions, reach out to me. I'll be in the Bugsnag booth.